Yes, my name is Kayleigh Johnson. As Alec already said, I am trained as a geologist. I got my bachelor's from the School of Mines and Geology, as well as a minor in environmental sciences. And then I went straight into my master's and got a master's in paleontology. So by training, I am a geologist and a paleontologist. I am an archaeologist as well, somehow. But I'm happy to be here. But this is a presentation on my master's research, so it is a large and long title, and this is edited. This is not the original master's title even. But really today what I'm going to talk to you guys about is dental microwear, and then basically the effects of sodium bicarbonate, which is baking soda, and how that can affect microwear, because it is something that we use in fossil preparation all the time. So first, what is dental microwear? Dental microwear is going to be the tiny pits and scratches that accumulate on your teeth as you're eating. So just as Aaron is snacking on his food right now, he's actually creating a pattern of wear on his teeth. And so these are usually classified as pits and, let's see, oh, it doesn't show up on the TV.
No.
We have pits, gouges, and then we have these scratches. So they're pretty easy to see. I'll talk about the pits later because I have opinions about those. But really all you need to know is that when you're chewing, you're making these patterns. And it's kind of interesting because these patterns will refresh themselves over a couple days' time. So you're always changing these tiny microscopic patterns on your teeth. So there are a lot of factors that will affect this microwear, whether it's your diet, what you're eating. So if you're a grazer, you're going to be eating a lot more silica-rich grasses, which is going to cause a lot more scratching than if you were eating a nice leafy salad. Other things that can affect this is going to be tooth structure or morphology. So if you're a carnivore versus an herbivore or an omnivore, the shape of your teeth is basically going to affect what pattern you have, as well as your behavior and your body size. If you really, are rough with your teeth or something like that, or if you're really chewing very hardly or very hard with your mastication, that is going to affect it as well. And then, of course, as a paleontologist, taphonomy is one of our biggest things. Taphonomy is basically the study of when an animal dies to when it is discovered, or in the case of archaeology, that might be humans as well. And one fun fact about microwear is it's something that we stole from the archaeologists and the anthropologists. It actually has its origins in anthropology. So it was used to study early hominids. In paleontology, however, we do use it mainly on herbivores, so our little plant-eating animals. So when we look at microwear, there are a couple different ways that taphonomy can affect it. So in the middle of the screen, we have more of a normal pattern of microwear that hasn't really been affected. Up in the upper left, we have an abraded pattern where you can still kind of see the microwear, but you can see that it's been worn down over time. Usually this is due to like tumbling in a stream or in the ocean or something like that. And then if you were unlucky enough to get eaten and digested, acid etching can also happen on those teeth as well. There have been some previous studies on air abrasion, which I'll define next, I promise. It's basically glorified sandblasting. How many of you guys have actually had air abrasion or some kind of abrasion on your teeth at a dentist office? Only Katie. That's okay. I have too. So in the dentist realm, they actually have done quite a bit of studies on this. So Vertalen and et al. In 2014 actually did this study where they treated teeth with air abrasion for 30 seconds at 50 psi and basically found that it does roughen up teeth. They used a very fancy machine to measure the roughness, and I'm not going to even try to explain the machine because I it's over my head, but all you need to know is that dentists have studied this as well. And then some paleontologists have also looked at how air abrasion with baking soda and dolomite powder can affect fossil teeth as well. However, their study was a lot more qualitative. Mine ends up being a lot more quantitative, and we will dive into that now. So air abrasion. Again, it's glorified sandblasting in fossil preparation. It actually has its origins in around the 1890s, if not a little bit earlier. And we basically use it to prepare very delicate fossils or areas of the bone that just are a little bit harder to clean by hand. And so typically we have a work cabinet, the machine itself, which usually looks like this. I used a Comco a lot when I worked with the Museum of Geology. And then you have a dust collector, so you're not like blowing all this stuff all over the place. There are a lot of safety inhalation hazards that go with this. Mainly we do use baking soda. It's not as hard on the fossils as something like actual sand, and it's pretty readily available as an abrasion media. This is a video, and I don't know if I'll be able to get it, but I wanted to show you guys what this actually looks like. And it's not the most glorified video in the world, because you can't really see exactly what's going on. But if you look, you can kind of see some of the matrix coming off as she follows the bone. I think this is a piece of mosasaur. This video is actually from one of the classes I took as a geologist back in the day from one of my mentors. But it's a really good way to get into some of those very small pore spaces and do some deep cleaning on fossils. There's actually other studies that have been done to kind of study the destructive measures of this. As you can imagine doing this work, if you don't have quite the right settings or the amount of abrasion media you have, you can easily powder and completely destroy fossils. So as much fun and as much of an OCD person as I am and like doing that, there are implications that go along with that. But nothing mathematically has really been done. And so my hypothesis with this is basically, or the questions I asked myself is, can this kind of air abrasion cause significant changes in the way that we have, or the way that we interpret microwear, and does it change those patterns in a significant way? And the really big piece of this is if these teeth that we're using in microwear studies have been affected by air abrasion in a negative manner, there's probably a huge bias in those studies. So onto my methods. There's a very, very particular way that one goes about studying microwear. We use the second upper molar in your mouth. So for humans, that's going to be our last molar before our wisdom teeth, if you even get wisdom teeth. And we specifically look at a certain cusp of the molar. For humans, I'm not 100% sure. I studied cows and horses, but we use the pericone. So this is a row of horse teeth. And I highlighted it over here since it's over there, but imagine that it's over here on this tooth. So I had to select my victims. Mainly the victims were selected based off of what I could find in collections and what I could collect myself. So I chose a fossil species and a modern species to try to control for the fact that fossilization has happened, and it might be different if I'm using modern teeth. So for my fossil species, I use Nannippus, which is a late Miocene three-toed horse. He's very cute. He's only about 3.5 feet tall at the highest. And then, of course, I use cow because we have a lot of ranches around here, and I happen to know a rancher who would give me a lot of cow skulls. So here's all the cow skulls. So I used upper molars of each animal and was able to have 16 and 17 individuals respectively for my horses and my cows. A fun side fact about the cow skulls, I found it was easier to do my process to rip the molar out of the skull. And that took a Dremel and a hammer and chisel. And if you've ever tried pulling a tooth out of a cow skull, it's really hard. I will never forget the smell of bone meal and grinding the bone. This isn't even the most gruesome because one of my cows that you'll see at the end was still partially mummified, basically. So very fun, very fun. And they came included with all the bugs and everything too. So like we put them in the collections room and all of a sudden there was like these spiders and wasps coming out of the skulls and we were like, oh no, that's going in the walk-in freezer immediately. So very, very fun. So once I finally pulled all my teeth out, the horse teeth were already singular, and there's a whole way that you can identify them to a second molar. If you want to hear about that, I'm going to skip over it for now, but I will happily talk about that. I cleaned all the tooth surfaces with ethanol. I molded them with polyvinyl siloxane, which is a great word to say. How many people have ever had braces? You've probably had this in your mouth. It is a molding material that they take a mold of your teeth to look at your bite or whatever else they're doing. It's a really fast-acting molding material, and it creates a very great mold for capturing that microwear. And then I cast it with basically a very fancy epoxy that is clear, so that when you put the cast into or under a microscope with oblique lighting, you end up with something like this. So you can actually see the microwear a lot clearer. So these were photographed at usually around 1 millimeter resolution and then zoomed in to about 200 microns. And then from that picture, I cropped it by 0.4 millimeter squared. And then this is the actual picture that I'm looking at for microwear. Again, this is like very standard procedure for how to do microwear. It might be very technical. I don't know why this is the standard. This is just what the daddy microwear paper told me to do. After I did all of that and counted the microwear, which was the easiest part, I treated the original teeth with abrasion with sodium bicarbonate or that baking soda. I'm obviously not an old man, but please forgive the picture. But literally it was 30 seconds at 50 pounds per square inch. That honestly was probably the fastest part of my entire thesis. And then I repeated the whole process of cleaning them and molding them and casting them. So I had a before and after mold and cast of everything that I did. Because this is destructive research, so like treating them technically with the air abrasion was destructive. And we wanted to see the before and after of everything. Okay, so this is where the math comes in. We're going to blow through the math because nobody likes math. I don't like math. But basically, I did a lot of statistics. And this is these statistics. So first I tested for normality just to make sure that the samples I had were normal. All you need to know here is that the cow was not for scratches, but it was for pits, which was strange. But I did have a smaller sample size. Usually you want a sample size of at least 50 to be more statistically powerful. In the case of paleontology, that's never the case because we don't have as many samples. But that's all you need to know for that slide. This is one of the more important slides. So after counting every scratch and pit in that tiny little photo, I did these tests. And because one of my populations was not normal, I did both the pair-T test and the Wilcoxon sign rank test, which one tests for a normal population, one tests for a non-normal population. And basically what I found is that there was a significant change in both the normal and non-normal tests in scratches for both my cows and horses. So the scratch number was changing at a mathematically significant way, and the pits were not for both animals. So what does this mean? What does it all mean? Why is it changing? Luckily, it's easy to look at pictures and be like, oh, spot the difference. So this is the same exact place on one of the cow teeth that I worked on. And you can see there's this really big scratch right here, and that actually matches with this scratch right here. But you can see that the original photo is a lot more detailed, there's a lot more scratches, it's a lot higher quality, and then all of a sudden a lot of that detail is just obliterated. So what we're seeing is that air abrasion is in fact destroying our microwear. If we go to our horses, this is another example for the pits. So if you look at the yellow here, these 3 little dots are pits. If we go over here, they're not there anymore. And then if we go to the red, there's like maybe 1 pit. If we go over here, there's suddenly all these new pits, and they're all completely different. This is, again, the same exact position on the tooth. So we're seeing that even though there's the same number of pits, it's actually new pits that have been created and the other ones have been erased. So the kind of the conclusions of this and most of my research is that we did have a lot of significantly different, or the counting and scratches was different. Okay. I'm going to talk about this one. I must have moved it for some reason. But if we look at the dietary analysis, these are my scratch counts, which is what we use for the dietary analyses. And basically what you end up seeing is that before they were treated, all of my animals were grazers. For the vast majority, some of them fell into browsers, which is kind of normal, just based off of condition of teeth. But after the treatment, they all became browsers. So 2 animals, our cows and our horses, which are mainly grazing animals, suddenly are classifying as browsers, which is more like our deer. So this definitely does have some implications of the fact that this treatment style could affect our dietary analyses. And I'm going to go back now. And this is kind of the biggest takeaway, is that if you're using a destructive method to prepare your specimens like this, which again is more common in paleontology than it is in archaeology. Luckily, archaeology, you just kind of have to wash things off and then bam, you're done. Fossils are embedded in rocks, and rocks are very hard, so it's a little bit more based in the paleontological side of everything, but really these past studies could be biased if this treatment was used. So with that, here's my gruesome cow.